Assalamualaikum and a very good day. My name is Muhammad Najari Sufian. My ID is MA17230 and I'm from Raut Pahang. Today, my team would like to present about the pump configurations. This is a pump background. In general, a pump is a mechanical system that when installed into pipelines, it transforms mechanical energy from an external sources into hydraulic energy, resulting in the flow of liquid from a low potential to high potential. Pumps are usually located at the source to increase the water level and at intermediate points to improve the water pressure in waterworks and drainage systems. The pumping station component design are critically need performance. So centrifugal pumps are often found in water and wastewater facilities, but understanding how they function and how to plan them is important. So here are some of the advantages of the pump types includes the following. So first one is simplicity of constructions, such as no valves, no piston rings, and high efficiency. Next is ability to operate against a variable head, suitable for being driven from high-speed prime movers such as turbines, electric motors, internal combustion engines, and etc. And lastly is continuous discharge. Next we go to the problem statement. So the fluid is usually pushed or moved by impeller solvent in the pump. If the fluid is polluted or combined with other solid particles, such as slurry, the issues will rise. Vibration will be felt by the pump because of the impact with the solid particles. The impeller or vent can disperse. Thus, we need to know the pump performance between the three types of the pump configurations in order to determine the best configurations to overcome the problem. This will include all the parameters such as pressure head, flow rate, power consumed by the pump, and etc. The relation between them are crucial in order to identify which pump has the highest performance. Next, we go to the objectives of this experiment. First one is to determine a pump performance with a single pump, series, and parallel pump configurations. Next is to investigate the relationship between pressure head, flow rate, power consumed, and efficiency for a pump. Next is to compare the performance curves of different pumps. That's all from me. Thank you.
Good day everyone. Okay, first what is the pump? The pump is the transferring a liquid from one location to another and circulating liquid in device. The liquid must be pumped into the device at a certain rate which necessitates the use of the pressure. There are some main components of the pumping system which is end use equipment which have different requirements and therefore determine the pumping system components and configuration. Second is valve. It's used to control the flow in the system. And third is the prime movers which is electric motors, diesel engines and systems. And fourth is piping and used to carry the fluid. Okay, the theory, the total power P of the pump result flow volumetric flow Q and the achieved pressure difference between the delivery and intake side of the pumps. Okay, these are the formula which total power can be get by the difference pressure times by Q delivery and intake side of the pump. And second is to find the efficiency is equals to P out power out divided by power in, whereas power out is can be get by the density times by GQH and P in equals to omega T equals to 2 pi n over 60 times by T. Okay, these are the formulas that we want to use to get the results. Okay, second, this is a pump in series. The H1 is from a pump 1 and H2 is from the pump 2. Okay, here the convergence in series which pump produces of 8H correspond to the flow, resulting H total equals to H1 plus H2. where H1 and H2 are the heads formed by the pump in the series at the same flow rate. Pump A produces the head 1, a capacity of the Q, while pump B produces the head 2 at the same capacity of the Q. Okay, the next is this one is the pump head against the flow rate. The graph is shows the pump head against the flow rate. Okay, next we would like to talk about the experimental apparatus. These are the apparatus we have used for the pump configuration experiment. First is the pumps. The two centrifugal pumps are connected together via pipes. Manual valve we have used to function to switch quickly between the series and parallel operations. Manometer to the function to indicate the pressure of the pipe system. And third is the water tank, the water which is stored in the tank. Okay, third, the experimental procedure. Okay, these are the steps we want to follow to get the result for the pump configuration. First is set up the multi-pump test rig and make sure all the parts are in good condition. And second is to switch on the machine and also the pump. Okay, third is fill up the tank with the water and maintain it to constant level. So we must maintain the water tank in the constant level and make sure that water level does not drop and empty when pump is switched on to avoid the pump is spoiling. Okay, fifth is to adjust the pipe configuration and connect it as the connection needed. Valve is controlled to using the single pump and configuration. Okay, sixth is to obtain the data from the sensors fitted at the pump. Fourth are used to detect the reading in the voltage from which is converted into the frequency. And strain gauge sensor is used to detect the pressure of pipe flow connection. Calibrate if there is any error during the data reading from the sensors. The experiments are repeated again from different connections, that is series and parallel pump configuration. Then the data will be recorded. Okay, these are the procedure that we want to use to get the result.
Assalamualaikum warahmatullahi wabarakatuh. My name is Emir Ishraf bin Shamukri. My matrix number is MA17235 and I live in Kuantan, Pahang. So let's talk about the results and calculation here. Results and discussion. So we start with the sample calculations first. So for the single pump, we have to find the head. So this is our equation, is P over rho times gravity. So we get the head. Then we have to find the power output, which is rho g q h. So we get 131.443 watts. And then we have to find the efficiency, which is N. So power output, this is P naught. So and Pn is given, which is 660. Then we can find the efficiency. So for the series pump, there's two heads. So there's head 1 and then there's head 2. Then we have to find the net head, which is the H total. Is H1 plus H2. So H1 is equal to 26.319 meter and H2 is equal to 31.082 meter, which is equals to 57.401 meter. Then we have to find the power output also, which we get is 257.243 watts. And then the efficiency, we get 0.195. So for the parallel pump, still we have two heads, H1 and H2. So H1 is equal to 27.714 meter and H2 is equal to 31.082 meter. Then we have to find the net head, which is the H total. For parallel pump, we have to divide our net head by 2. So 27.714 plus 31.082 divided by 2 is equal to 20.172 meter. Then we have to find the power output, which is equals to 151.449 watts, and the efficiency. So this is our graph of flow rate against pump head for the single. So the graph correlation shows that the pump head decrease as the flow rate increase. This relationship states that the pump head is inversely proportional to the flow rate for a single pump. This is also the same for the series, where the pump head is inversely proportional to the flow rate also. So for the parallel, also the same. This is our comparison. So it is all three different configurations of pump have similar relationship between flow rate and pump head. They all are inversely proportionally related. And the series pump configuration recorded the highest pump head, while the parallel pump configuration records the lowest pump head compared to others. The head in series pump configuration is higher because the pump head is obtained from adding two single heads at the same flow rate. So we end here with the conclusion. So we fulfill the objectives and the scope of the experiment report. In the pump configuration lab, we will conducting experiment to determine the pump performance with three different configurations, which are the single pump, parallel pump, and series pump. And we obtain the delivery pressure, the suction pressure, flow rate for each configuration, outflow pressure, net head, power output, and efficiency of each pump configuration. So this is all from me. Thank you very much for listening.